All right, so before we start this meetup, I want to do a few things that we don't normally do. I'm going to call out Fiddler AI because they are an incredible support to the MLOps community. And I think it is worth mentioning that they have sponsored the community. And with that leap of faith, it helps the community grow. It helps the community be what it is. So I want to thank them from the bottom of my heart. They are one of the first sponsors and they're taking the chance on us. So that being said, let's get into this talk with Krishna. It was an incredible deep dive on explainability and why we need it, what it is, all of that, responsibility when it comes to machine learning. Here we go. And then there is another thing that is pretty cool about today's meetup, which is Krishna Gade. He is going to give away some Fiddler swag to some of the best questions that are asked throughout the meetup. So if you have any questions today, throw them in the chat and you're going to enter yourself into the raffle to win some swag. That's not a bad deal. If you're, I might ask some questions too, because I want some Fiddler swag. So
got some good swag there.
Yeah, that's it. Just kidding. Asking questions is my job. That's what I'll be doing this whole time. So today, in case you missed it, we are here to talk about how explainable AI is critical to building responsible AI. And let's start first, before we jump ahead with any of that. Let's start with you, Krishna. I know that you have a long history in this explainable AI world. You were one of the people that decided to put at Facebook, why am I seeing this? And then later that trend caught on. We can see it in most large platforms. You have some kind of explainability that tells you why you're seeing something when there is machine learning involved. And you also have gone off and you said, well, you know what? I like that idea so much. I want to start my own company around that. And that is Fiddler is doing monitoring solutions and they're also doing explainability. And so that's absolutely incredible. But before we jump into any of that and the talk theme and all that we came here to talk about today, can you just give us some background on yourself? How did you get into machine learning? How did you even get into tech?
Yeah, absolutely. Thank you, Dimitrios. Thanks for the opportunity. Thanks, everyone, for joining the call. And first up, it's our pleasure to be part of MLOps community. It's a rapidly growing community, so feel free to join. And very super interesting questions and people coming from various different use cases in operationalizing ML. So yeah, I mean, I'm like an engineer by background. I came to the States in 2001 to do my grad school from India, and after that, I landed my first job at Microsoft, working as a software engineer at Bing, which is actually where I got exposed to machine learning. So Bing was building this search engine to compete with Google. And one of the things that they wanted to do was to invest in, like machine learning algorithms, especially neural networks. Back in the day, this is like, early 2000s, where they had a, very good like set of Microsoft researchers, at the time that, we were working with them to kind of productize neural networks. I mean, single layer neural networks, 2-layer neural networks, not very complex neural networks, but still, quite complex to the state of the art, search quality algorithms at the time. So I remember at the time when we deployed our first neural net, I remember our developer manager just basically expressed this thing where, we just lost control over search quality algorithm. Because until that point, we had a very simple configuration file with like weight specified for each parameter, and anyone could just see like how the search ranking algorithm would work, right? But the moment we switched it to a simple 2-layer network, it just became a black box. So the very first explainability tool it wasn't even called Explainability. Was a debugging tool that I and another developer built. It was called Query Probe.
Wow.
And I think it's one of those query debugging tools that I think Bing still uses. it basically helps you to kind of find out why you are seeing a particular search result for a big search quality. So my foray into explainability started kind of unknowingly way back almost 15 years ago, and ever since I've been working in tech. I've worked in various different parts of like Bing, like you know and the nice thing about working on a search engine is you work in like kind of a cross spectrum of like distributed systems, algorithms, and scalability. You get exposed to a lot of concepts there. After that, I came to the Bay Area, worked in a bunch of social media companies like Twitter, Pinterest, and Facebook, where you're obviously exposed to a lot of large scale data, analytics of it, and sort of how do you make sense of that data. And it is at Facebook where I kind of life came full circle, where Facebook I joined Facebook around 2016. And we at the time by the time Facebook had invested quite a bit in machine learning. We had the FB learner system that people were using to create machine learning models. It was like kind of our machine learning platform. And Newsfeed, which is the team that I was in, was a heavy consumer of it. And so we would build lots and lots of machine learning models, and very complex ones, sparse neural networks, boosted trees, and at the time, we kind of sort of lost this ability to diagnose these questions that would come from publishers or internal employees. And especially after the whole 2016 elections and all of the other things that came after Facebook, we felt that we needed to increase more transparency among our algorithms, first internally, especially, and also for external users. So that's kind of where we started working on. So I was leading a team called Feed Ranking Platform, which is providing the infrastructure for the ranking engineers in Newsfeed. And so part of our responsibility was to create toolkits to debug and diagnose machine learning models and help them and explain them to a wide variety of stakeholders, starting with developers first. And we would get questions all the way even from Zuckerberg sometimes, why am I seeing this story in my feed? Or why is this story going viral? And previously, before these tools, it would take a long time for developers to do this debugging exercise, right? And it could be like, there could be n number of problems that could be going on. It could be, a bad model got rolled out, kind of Facebook had this continuous machine learning update process, or it could be that someone was in an experiment that they were not supposed to be, right? Like, and so there was A/B testing of models happening, or it could be some bad data pipeline that sent bad features. So a lot of these things helped us improve the infrastructure, improve like the sort of the operations of it. And so that's kind of what I felt at the time. To kind of just to continue your question is sort of that's when I felt that a lot of work in machine learning to that point was happening more around helping data scientists create better models, like accurate models. Automated machine learning platforms were coming out. SageMaker just launched around that time, but we felt that no one was actually looking into this aspect of monitoring and debuggability of machine learning models, and that's kind of what prompted us to start the company.
That's great, man. And there is something that you said there at the beginning of your journey that I think is fascinating, especially because you were doing it in the early 2000s, you said.
Correct. Yeah, it was like 2005-ish, which we launched a two-layer network, and we had to build Query Probe, a debugging tool.
I mean, you said that this is what's incredible to me is that everything was fine when you were doing it behind the scenes, but then when you put it out into the wild, it was like, whoa, we just lost our baby.
Correct.
It's no longer under our control.
Correct. Especially for a leadership part, right, where you can just see, hey, like which feature is contributing how much, so they can you want to have that assurance, how is the system working, even if it's working fine or even if it's not working fine. So.
Yeah, that's incredible to think about. So let's move on to explainability and responsibility. I know they are hot topics right now, especially I think even more because the social dilemma came out and more people are starting to focus on the governance of machine learning and also the explainability and the responsibility of all of this. So I think we should probably start just by talking about what is explainability besides you saying, okay, if I'm a consumer of a news feed, I can just click a button and know why I saw some article, right? What else is explainability? Can you break that down for us?
Yeah, absolutely. So I think fundamentally, if you think about, if you take a step back, the new software artifact that is getting operationalized today is the machine learning model. For example, back in the day, most of the software used to be, like just like, code that you write and you can actually see what you've written. You can debug it line by line and you can actually understand it and by spending time at it, right? But the new software artifact that is going into production is this probabilistic entity or a stochastic entity called the machine learning model. And there are a few aspects of it that actually make it interesting. One is it's a black box. Even a simple logistic regression model, it's not something that you can open up the code and read all the rules, right? Like even a decision tree, you cannot see, what rules got invoked when a particular prediction was made. So first of all, it's a black box entity that you cannot actually open up and see. Secondly, because it's a stochastic entity, its behavior changes based on the data it's receiving, right? So you may have trained it with certain set of data, and when you actually operationalize it, it may be getting different types of data sets. So therefore, its predictions can be something that you may not like you may not be able to guess. They can be across a bunch of they can be spread across a bunch of range. So therefore these two things of not, like, I wouldn't call it non-deterministic, but kind of it's not theoretically not deterministic because it has a finite range, but it's still kind of non-deterministic from a human point of view, the way it behaves in production, and the fact that it is a black box. Those two things make it a very hard problem, hard thing to operationalize. Now, if you operationalize it without properly testing these things, properly understanding how these models, then there is this whole quote unquote irresponsible practice of machine learning could come into picture, especially if your models are being used for some high stakes use cases, right? So for example, if someone is using machine learning models for issuing loans, right? Now we all know that like things like jobs, getting a loan approved, getting a house mortgage approved, they're critical aspects of human lives in society, right? It can be life changing, if you get that particular job, or if you can get like that loan sanction or whatever clinical diagnosis and all. So for those high stakes use cases, machine learning models are being applied because you have a lot of data collected and you have a lot more information about the users, and you want to provide the more accurate, I mean, in a good spirit only. And so essentially you want to provide more accurate more experience to the customer, and you can actually simplify your operations and whatnot. But if you do not actually know what you're doing with these models, if you don't understand how the model is working, and if you have not properly validated it, tested it, monitored it, then you cannot be saying that you have a you're sort of make your systems are making responsible decisions, right? So the whole concept of responsible AI is to ensure that a particular set of processes are sort of implemented. It's a process framework so that you can think about when you're training and deploying machine learning models, what set of things do you need to think about. So starting from the training data set and assessing biases in training data sets, and then validating machine learning models, and then once you validate them, monitoring them and being able to debug when people ask questions, and having those capabilities will set you up for a responsible AI practice. And so that's kind of how you define it. Within that, explainability becomes a core concept, because if you do not understand how the model is working, that's the fundamental part of it, right? If someone asks, how did you make this prediction, if you do not understand it, then you can be sort of you really don't know how your system is working, right? And so explainability becomes the center of it. It becomes the cornerstone technology to actually have in place for you to actually build responsible AI in production.
And so when you're looking at the responsible AI, of course, the use case of these high stakes machine learning models is very obvious, right? And I know, like, I think the epitome of this is there's something in Florida where the judge decides who gets out on bail due to a machine learning model, right? That's like the epitome of a very high stakes machine learning model. And you want to be able to explain why it's making those decisions. Turns out it was pretty biased. And I think everyone's heard that story before, so we don't need to go too far into it. But what I want to know is, for those use cases that aren't as high stakes, do you still feel like it is important?
Right.
And how high up the food chain? Like,
Yep.
is it just something, because I think about the people in the community that are trying to just get a model out,
Right.
and then you tack on, oh yeah, you want to make sure it's explainable, you want to make sure it's responsible. I have my own personal thoughts on this. Like,
Right.
you shouldn't be putting something out unless
Right.
you can explain and it is responsible. But
Right.
I'd love to hear what you think about that too.
Yeah. So increasingly, what's happening is use cases that you've never thought would have these kind of implications are emerging. So obviously, we talked about the standard set of use cases, the credit underwriting, clinical diagnosis, recruiting, which directly affect the human beings, need to be companies need to be putting in responsible AI practice. And we have seen all the incidents, whether the Apple credit card gender bias
Yeah.
incident, or the Amazon recruiting tool kind of bias incident, or many incidents in the past that we have companies had to roll back tools, or had to kind of do PR correction, or kind of regulatory probes happened and whatnot, right? But if you kind of think about it, like there was this UK logistics company called Deliveroo, and they got sued by an Italian court that they were actually issuing these, sort of delivery orders for different people at different times, and they were actually being biased towards against a certain set of people. Now, you wouldn't think logistics as a in the as a company that would actually need to think about responsible AI before, right? But if you step back, we are actually using all these services like DoorDash, Uber all the time, but there is an element of are these algorithms working in a fair manner, right? Like, are these
Yeah,
are
sure.
these basically trying to sort of provide sort of employment in a fair manner, give orders in a fair manner. So there's a whole, I mean, it's once you open up it becomes like a can of worms, right? You can say the same thing about, say, a housing marketplace company, right? So I think you can see that there's so many hidden biases that you can actually uncover, even in in use cases where you cannot they do not directly touch human beings. Now, having said that, if you're just using machine learning for like something that is completely internal, that is like, let's say, it's not touching human beings at all, it does not have any implication of it, would you still need monitoring and explainability? I would argue that you would, if your models are critical for your business, right? Let's say if your model is actually critical for your business, not something that you're doing some for your own research, you want to know how it's working? Don't you want to understand how it's actually making its decisions? I think it makes in our experience, what we believe is you can actually use these insights to make the model itself better over time, right? The ultimate goal of it is, one is obviously to explain it to others who are asking you questions, so that you have these insights, but then also use these insights to make the model better. Right. So now we are seeing this emergence of whole model robustness and adversarial testing, the whole sort of research fields emerging, where now how can you use explanations to make like the model better, right? And one of the customers that we are working with is basically trying to use like false positives coming out of their model, and then using explanations for the false positives to kind of derive sort of synthetic training examples, so that they can address that false positives, a segment of false positives, and make the model better. So there are multiple use cases of explainability, not just explaining to third party, but also to for our own sake, to make the model better.
Wait, can we dig into that use case real fast? So the false positive is coming out,
Right.
and then they're going back and they're training with that false positive to not have that false positive again.
Correct. So I can't name this customer. It's a very high profile customer, but let's assume this scenario. Let's assume the simple fraud case scenario. So you have a fraud model. It is detecting fraud, and it has a set of false positives. Now, first of all, you want to know, when you actually are running model in production or about to launch it, you want to know what are all the failure scenarios, which segments of data it's actually not going to predict as well, right? And so explainability and a tool like Fiddler can help you uncover which slices of the data is the model is not performing well on your own train and test sets. Now, you can actually also do it in production when you're actually, you can say, let's say I want to run this model, and I've observed it over a week or a last month, and I've seen, these are the cases my humans have labeled, these are all false positives, right? Now, from those false positives, you as a developer in the past, what you would use, you would actually look at and detect patterns to see, okay, this is where the model is failing. For example, people coming from, transactions coming out of, San Francisco, from this neighborhood are being classified as fraud, or transactions coming from Nevada from this, region are being classified as fraud or whatever. And you try to detect those yourself as a human, and then try to go and say, do we have enough representation of those in positive examples and negative examples, because they are all misclassifications, and can we kind of train the model so that it can actually learn from it, right? Now, that process, it's harder to do when you have a lot of features, when your model is very complex,
Yeah.
when you do not know the reasons how the model is predicting. Right? Imagine if you had model that is actually, explainability can give you attributions. Okay, these are the reasons why these transactions are classified as, fraud, but they're not fraud, right? And so now you can actually group those attributions, and from there you can have these clusters of attributions which will give you these, common sets of reasons, which can then, help you, come back and say, okay, where do I get, what's the problem? Is it a feature? Do we have good features for these set of, people, or do we have enough training examples, right?
Uh-huh.
Or is the model not good enough, for these type of things? So we may have to train a different model architecture. Maybe we have to go for instead of one single model, we have to build like an ensemble of models. So those are the things that you can actually do it. And this is very common practice in companies like Facebook, where we would basically, when we try to look at a model performance, we would look at it holistically, but also look at into segments of it. And when we and the same model may not perform well across all regions. So it's very common for people to build these ensembles of models so that it can address like the weak spots within the data, and then they all come together to make a decision, right? So explainability helps you kind of, get these insights, do this at scale instead of a human going sifting through the data and, collecting patterns.
Yeah. And it feels like if it is a human doing it, there's a lot more room for error
Correct.
and a lot more. It's almost like bias could be introduced, or the theories could be introduced, and then they have no basis in reality.
Yeah, I mean, you have to have an expert human being. I mean, machine learning is part art, part science. That's the reason, right? You have this, a machine learning, the subject matter experts who some of them are, have this really good intuition of what would work, what not doesn't work. But what will happen is, tools like, explainability tools can actually, provide these insights for a wide variety of people, so that, a lot of data scientists, a lot of developers can actually, take advantage of it, and then, make sense of how do they address, model
Well,
improvements and whatnot. So that's I think, I mean, I believe that, most humans, want to do the right thing, especially the developers who want to, like, are doing machine learning. And so there's no, like, people are not purposefully gaming the system, right? But there could be, issues where you may make errors. You may have not, you may have not looked at the training data set. You may have not looked at if it's actually having enough like samples for each type of user or each type of case. And whether that's actually bias related thing that could actually affect your, kind of use case from a bias angle, or in another way, it could actually just affect your model from a performance angle,
yeah.
right? In the fraud example, it's may not be biased. It's just that it's mispredicting, transactions coming from two cities, to be like fraudulent, and it's just probably a performance thing, performance improvement problem. Whereas if it's happening with like, it's affecting like a whole gender, like a whole set of population coming from a certain place, to be like all fraud, then that would just translate into the bias fraud. It's the same thing, but depending on the context, it becomes like a performance issue or a bias issue.
So do you need this subject matter expert or someone who is very advanced to be able to set up what the explainability tool should be looking for at first, or is it something that's plug and play and it will know when it like latches onto the model?
Right. So the goal is, I mean, the goal for companies like us for Fiddler is to provide as many insights as possible, so that we can actually make like data scientists' life easier, right? So you can actually, by helping provide you debuggability to these things, even not just the expert data scientist, but also like more junior data scientists on their team can also learn from these insights and start making models much better, right? So That is the goal. And eventually, right now, like our platform supports, for example, you being able to like slice and dice data and explain, parts of the data with your model. But also, in the future, we may be also like kind of looking at, like kind of as I said, recommending slices. These slices are actually not performing well for your model.
Brilliant.
Now and sort of automatically providing recommendations, so you can go and actually look at those slices and actually address performance issues.
Man, that is super cool. I see some questions coming through in the chat. So
Sure.
there are some people who want some swag. Remember, if you ask a great question, you are entering to win some Fiddler AI swag. Krishna has been kind enough to give out some swag to a select few that ask the questions. Now, let's see here. This is an awesome question from Shabi. Can we measure explainability or measure the accuracy of the explanation? Do you think that we need such a metric to regulate sensitive models?
Yeah, it's a very good question. Evaluating explainability algorithms is a very hot topic in research today. First of all, what are the things that you want to evaluate on, right? There are many things, right? So, for example, one of the things that you want to care about is the explanation high fidelity? For example, are you making up an explanation, or is it actually high fidelity to what the model is actually trying to do, right? uh, and so that's very important. And then, is the explanation intelligible? Is it actually, for me as for human, can I understand it, right? And so there are various ways to evaluate it. We are also sort of working on coming up with our own metrics. One of the things that is actually shining through with explainability algorithms is some of these algorithms, especially the ones that are coming out of the class of attribution based algorithms. So they all under this family of Shapley value based techniques. And so the nice thing about those Shapley value based techniques is that they have this sound game theoretic axiomatic principles. So they have certain axioms that theoretically proved by this sort of economist in 1950s, that actually help us. For example, so just maybe getting into a little bit of Shapley values here. So Shapley values was essentially designed to sort of take, in the game theory, to basically take like a profit of a game and split it into rewards among the players, right? So for example, if let's say three people come together, start a company, and the company starts making profits, how do you take the profits and split them into bonuses? Now it's being applied, the same concept is being applied for machine learning models, where a bunch of features come together and they make a prediction, and now you take the prediction is your profit. Now you take it and split it into among in the feature rewards or attributions. So these are all called attribution-based algorithms. Now Shapley came up with these really nice axiomatic principles saying that if two features are actually identical, then they would get symmetric Shapley, or if they're symmetric, then they'll get identical Shapley values. Or if a feature is as a no-op, then it will get a zero Shapley value, or all the Shapley values add up to the total prediction and whatnot. So some of these axioms help us kind of provide a solid grounding. So we see that Shapley value-based techniques are actually becoming kind of almost the gold standard in terms of explainability. There are a bunch of techniques that build on top of it. There's integrated gradients. There is, which is like a variant of Shapley values, an Aumann Shapley value technique. We have our own implementation of Shapley values using norm theory. So there's a bunch of techniques that build on top of this core concept that provide these sound principles. However, yeah, we still need to ensure that how is this metric, right? Like how what is this explanation, can I trust this explanation? So today what tools like Fiddler provide is ability to do what if analysis, so that the human can themselves assess like what if I change it, what if I change this feature value to this value, what would be my explanation, or what would be my prediction? So therefore, by interactively playing with the model, you can actually understand it much better. And so there are basically those are the experience, the user experience is kind of trying to come together to kind of make it like more trustworthy. Ooh. But yeah, in the future we would have to have these kind of metrics that kind of can quantify the value of explainability.
Well, that just, we can jump on the next question that's coming through, which is another great one from Sandhya. Forgive me if I pronounced the name wrong, but it goes, we can just pin this onto that, because They're asking, does explainable AI also entail explainable data?
Mhm.
I see the point where explainability can help with getting the insights about data after the model has been
Right.
trained, but should it be handled perhaps more proactively, where you unbias the data before training the model on it?
That's a very good question. In fact, one of the things that we actually have the tool provides to our customers today is, so when you're doing feature selection, when you have a lot of features within your data, you can use explainability not just after the model is created but before it, to actually see which features are actually the most important features, which features can be pruned away. And to Sandhya's point around like preliminary investigation of feature importance, and which features are coming up, are there any, like looking at feature correlations and PDP, like partial dependency plots between features and predictions, so you can get some idea before even go deeper into feature engineering and model building exercise. So yeah, there's definitely a valid point there. However, one should remember that explainability is only giving you a lens to look into the model. So even if you're explaining the data, you're looking through the model's eyes, right? So it's not causal from a data point of view, right? So it's not like, for example, it's not going to tell you, like, if for example, if a store is not going to make sales because of an external event like coronavirus has happened and people stopped coming to the store, right? You cannot, that those things cannot be captured. So explainability is limited, and it's very important to understand this thing. It's essentially giving you the eyes to look through the model. And the model is basically, what is the model is basically learn from the data and developed a pattern from the data, right? So you're essentially looking through the model's eyes on the data. So that's what you're doing with explainability. So there are, you can stretch this thing and get into like causation and all, which is has to be, sort of, a little bit careful you have to before you do that. So it's still, you're still going through the model's eyes to understand the data.
Man, I love this shit. This is so good because this needs to be happening, right? Like these questions need to be coming up. And I argue for everyone being able to explain what is their model doing and why
Right.
and all of that. And I'm glad to see that others are asking questions. Maybe it's just because we're giving out some swag, but I think there's some genuine interest here because there's some incredible questions. We've got one from Deepesh who's asking, as a data scientist, there are situations when the prediction output is expected to support a business decision taken by senior executives. Uh-oh. In that case, when the explainable model gives out a prediction that doesn't align with the stakeholders' expectations, how should
Right.
one navigate through this tricky situation?
That's where explainability becomes your friend, Deepak. So because that's actually that the hippo decision making, the highest paid person, in the office, right? Hippo, it's called hippo decision making. So, and so that exists in many industries. And it's, yeah. So when your model prediction does not match with this, senior leadership's decision, you can then go and explain, here is why that is the case, because they generally would naturally ask, hey, like, I don't think my intuition tells me this, or my experience tells me this, right? But you can actually open up like the model and look at, like, tell them, and they can actually play with themselves. For example, let's take this simple scenario. So let's say I'm a very experienced underwriting officer in a bank. I'm like 20 years of experience underwriting loans. I know what makes a good loan, what makes a bad loan. Now suddenly a new loan comes in and it's marked as, very high risk. And I think, like, no, it doesn't look like high risk. I have approved these type of loans in the past. Why is the model saying it's high risk? Now, if you can actually explain that, saying that, hey, the reason why is because this person's, loan amount is so and so, or this person's, FICO score is so and so, or his previous debt is so and so and whatnot. But and then also provide more examples, say, hey, these were all the other loans that look like these loans that we actually denied in the past, and they were actually bad loans, or we actually approved them but they turned out to be bad loans. Or where you can provide some ways for the person to actually change like variables and make sense of their own self. And so this obviously becomes like a collaborative exercise. Now in some cases the model could be wrong, right? And this is where explainability becomes important, because when you are designing the model, if you have not selected the right data set and whatnot, and the subject matter expert can actually be right, and they might be able to guide the model building process. In cases where the model is right, then they can actually correct their own kind of intuitions. So it brings both parties together, and that's the beauty of it. And by opening up this black box, you actually not just like have like the data scientist telling that this is what the model is doing. And in the past, that used to be the case, right? In the past, when I worked with data scientists, when I would ask, what's this prediction, and they would be like, I don't know, the model said so, right? So that both like kind of takes away the credit, right? And we understand, as an engineer, we understand, yeah, it's actually hard to answer that question, but but having that opportunity to expose that insight, brings multiple parties together. We can actually have a dialogue and have a consensus to move forward.
Great answer. And this is a bit of a tangent, but I know that when we as humans, they did a study on us, when we see something that comes from a computer or a machine, we are much more likely to believe that it is true. And so you get into these situations like, oh, well, the model said it was this.
Right.
And so you just take it for granted without actually
Right.
digging behind and saying, is it right? I mean, I'm sure the people on this call, they don't just take everything without a grain of salt. But for the majority of people, we're used to calculators putting in numbers and spitting out an answer, and
Right.
it is the right answer always, And if it's the wrong answer, it's because of something that we did. It's not the other way around, where the machine learning model is just doing something and then we get an answer and we're not sure if it's right. So that's a side note. I've got more questions rolling in here. There's one from Sherry asking, how do you differentiate explainability from interpretability, and how important is each in what context?
Yeah, so I mean, these are all obviously industry terminology. Right now, they kind of the definition that is becoming more popular is I can at least think about it, interpretability, as interpretable machine learning algorithm. If the model itself is interpretable, for example, let's say one can argue that a decision tree is interpretable. If I can visualize the decision tree, I can see which path prediction is taking. I can actually understand it. I don't need a separate explainer for it, right? Same thing, a linear model could be interpretable because I have the weights and coefficients, so I can actually have interpretable. So you have this axis of interpretability where the model itself is interpretable, maybe in the case of a linear models, or a decision tree, to like completely black box where I cannot like interpret a neural network. Explainability is more around kind of taking a model and then explaining it as mostly kind of in the context of a post hoc explanation, right? So in this case the model itself is not interpretable, and you're trying to explain it to a sort of a third party or for yourself. And so that's kind of how I differentiate it. So you have interpretable algorithms, you have the all the way from linear models, decision trees, GAMs, which are getting very popularized, then all the way to like like non-interpretable algorithms like neural networks. But then you have explainability algorithms, which are taking any of these models and trying to explain it in a way. We talked about Shapley values, Lime, and integrated gradients, and many other algorithms that are coming up. That's kind of how I would differentiate it.
Okay, so there's another one from Fatime, and they're asking, how useful do you think causal ML can be to the explainable AI agenda?
Yeah, so I mean a lot of so I'm not an expert in causal machine learning. So from what I understand, obviously, if followed Julia Pearl, and I sort of read the Holy Grail, the Book of Why, and all. So I think a causal ML is all about you sort of trying to as a human providing a lot of structured information to the model, kind of the sort of the relationships between the elements of the data a priori, but from your own subject matter expertise, and then sort of use and baking that into the model, right? So I think that's great if you can do that. Now you can actually help it'll help you sort of understand how the model is working. But however, it's really hard in practice to be able to do that, right? For a designer to come together and actually associate the sort of these sort of put together these definitions in manual. Because what's happening is, the reason why explainability is becoming so popular is because of the emergence of deep learning, right? And what deep learning has done is it's basically taken that you have all of your data, just throw the data into the model, let the model figure out the feature combination, let the model kind of train like which pixels are the most important pixels, or which word combinations come together to make like the say sentiment of a piece of text, or which features in a structured data sets come together to make it to make it like let's say a fraud or non-fraud. So that in those cases the model is actually deciding those patterns, and it's using and it is human is just basically supplying the input, right, supplying the data almost like a raw data set. And therefore that and so there's no sort of you're not sort of sitting and designing the relationships yourself. And so this is where explainability is becoming more important, because you have these deep learning models being developed by users because they're getting very high accuracy, and then now like as at the cost of interpretability, and so therefore you want to kind of address that. So that's kind of where we are seeing the increased usage of explainability.
We got more questions coming through in the chat. It looks like people want some swag. We didn't even tell them what it was going to be. What if it's such a letdown at the end? We just say, all right, we'll send you a sticker. All right, it's not going to be just a sticker. That is for sure. Krishna said it was going to be something cool, and I trust him. Now, Philip's asking, you've been talking a lot about decision trees. Are methods like born-again trees, which aim to approximate models by decision trees, traceable for complex models? And this, I guess, I'll just tack on a question to this. Are there certain models or methods that are harder to explain than others?
Yes, I mean, for example, even like if you have a hybrid neural network that can take multiple types of inputs, right? Like for example, let's say you're trying to let's take that credit card fraud example, right? So you have a credit card fraud example. Now, along with your structured data sets, so for example, my like previous credit card debt and how often I was repaying and whatnot, you can also take a sequence of all of my previous transactions, all of my previous sort of like in sort of as a sequence instead of like a structured data set. So you can build a hybrid model where certain set of inputs are like more like kind of a tabular data like inputs, certain inputs look like sequences, and so now you can build like LSTMs or kind of the very complex models, complex ensembles. Now you have this layered ensemble. How do you then explain it? And you want maybe explanations at different piecemeal levels, right? So this becomes a very hard technical challenge, and we are seeing the emergence of these type of models come up. And then obviously reinforcement learning, which is also kind of it's actually where the model is actually all the online learning model algorithms. So the model is actually continuously retraining. Those are models that are hard to explain in practice. And so those are the types of models where we feel like it's these some of these a lot more sort of research has to happen, and there's like explainability today is like a little hard to apply. And so I think the basic techniques remain the same. It's about basically being able to apply them at various different levels, and how do you then apply to get a model that is changing constantly is the hard problem. And then the other question was there another question
about
in that
decision
question?
trees? And
correct, yeah. So yeah. I don't know the other type of decision tree that was mentioned. So I mean, the most popular decision tree, like obviously that's in practice, is the boosted decision tree for almost all structured data sets that people have today. BDT has become kind of the state of the art, right? So it provides really good accuracy, and a lot of people use it. And so and explainability works very well for those for boosted decision trees. And in fact, Shapley value-based algorithms work really well for boosted decision trees in practice.
All right, so here's another one, a bit in the weeds, but from Irv asking, how useful are, and this is how, denen clustering for data explainability?
Yeah, so I mean, I think this is probably coming to like given a data, how like kind of building like some sort of hierarchical clustering on the data to understand the data itself. As I said, data explainability is around given my data set, what features are important, what feature correlations are coming through, which features are actually are sufficient, so you can actually prune away some old features and save some costs if it's like a very high like a large data set that you have to train, or like bias related questions, which features are coming together to introduce bias into the model. So all of those things, are various different approaches to do it. One approach that we do take with Fiddler is to train like an interpretable model on the existing training data, and then exposing these insights through explainability, so that it's basically you bring us the data set in Fiddler's models, explain the data set by training the model. Again, we're looking at the data through the model size. And the reason why I think this is actually more effective than maybe a simple, I think, clustering based techniques, which are, because these are, in my opinion at least, this is actually kind of modeling the problem that you're trying to solve, right? And if I'm actually trying to come up with like a churn prediction problem, and I want to know what are the features that are important, so I know what are the features that are not important. By building a first pass model that actually tries to predict churn with reasonable accuracy, you can then understand how the what features of variables are important, what features are not important, how
Oh,
different features are
nice.
coming together to influence the prediction, and how the model, how is like the data distributed across different segments of population, how the features are distributed, and whatnot. So that's kind of what we found more effective in practice than going down the more unsupervised way of analyzing, which I think is also useful, but I think we found this is actually much more
Wow.
effective.
Yeah, that's really cool. So I'm going to take one real fast, and I'd love to talk about the challenges that you see right now with explainability. Is it the what we touched on before, how there are some models and there are some methods that are really difficult to explain,
Right.
or are there other things that jump out at you?
Yeah, so I think there are, first of all, there's obviously there are multiple challenges. One is explaining complex machine learning models is a challenge. The other big challenge from a practical standpoint, and this is something that we sort of working on at Fiddler, and then kind of have solved quite a bit, is building a general purpose explainability platform is really hard, right? Because today, unfortunately, models come in all forms or shapes, all kinds of formats. Different formats
Totally.
don't agree with each other. TensorFlow, PyTorch, scikit-learn, XGBoost, and you have all the old school formats like R, SAS, and all. How do you take all of these models and then build a general purpose explainability platform? From a technology point of view, it's hard, because ingesting the model and running the model and actually inferring the model, and different APIs in the model. So one of the things that we were excited about was this whole open neural net exchange project that came like a few years ago, which was trying to standardize model formats. I think it was started by Microsoft, Facebook, Amazon as a consortium. And so if we have such platforms in the future, it's almost like a Java bytecode for models, right? So if we actually have like a one standard format for models, then it would help for in the future for a lot of data science teams to have like a general purpose explainability thing. So that's number two. Number three is, obviously, we talked about the sort of the evaluation methods, right? So how do you evaluate explainability? How good is one explainability algorithm or the other explainability algorithm? That's still a topic of research, and sort of people are looking into it. So those would be the kind of the three things that I would say.
So there's a few more that are coming through here in the chat. Is explainability only for humans? For example, machine learning predictions can bypass physics itself, like this model which predicts planet positions directly from data without Newton's laws. Is humanity losing something here when gaining something else? And are we only trying to help us feel we understand how the model works? That is a
Yeah,
great
it's a
question.
very
It's a
interesting
deep one.
question. That's a very deep one. So I'm not thought about it that much, but I think there is always a human in the loop with machine learning, right? I mean, we have not gotten to a state where systems are completely automated end to end, where the systems are auto learning from their mistakes. So even there, I believe that once you have once you have this flywheel where you have a model that is trained, and you have a model that is deployed, and it's now being monitored. Now, if you can actually, automatically retrain the model, kind of, sort of, keep it like almost like a cruise control, right? Where, it's essentially, it's just on its own, and the system is retraining better versions of the model. And even there, to come from like the old model to the new model, it requires insights, right? How do I, let's say if the model, you may want to retrain the model because the model is drifting in performance, or it's throwing a lot more false positives, or whatever reasons. And from there, from that snapshot of like model M0 to like go to M1, you need like explainability. Whether the machine is consuming, in this case the machine is probably consuming the insights and saying, okay, these are all the segments of data where the model is not working well, and maybe there's like a workflow where I magically get like some synthetic training data sets, right? So and sort of automatically retrain the model. But I believe that before we go there, there will always be human in the loop, because at least we want to see like which were false positives, and then you can go and sort of human goes and looks into it, and there is like and they would then go and like see how they can actually retrain a better model for putting into production. So, but yeah, I think whether the human is in the loop or not in the loop, you still need the insight, because ultimately explainability is to find bugs or performance or problems within the model, right? Or explain the model and also find issues within the model so you can actually make it better. That's the whole point of it at the end of the day.
Well, I want to dive into the idea that you presented earlier before this question, and shout out to Ron on that question. That was one I did not see coming. So the idea of the difficulties that you were talking about and the challenges, and how to make a tool that is able to span the whole spectrum right now, because there are so many different use cases and there are so many different models and frameworks and
Right.
deployments and all of that. How do you aim to conquer that as a company? Like,
yeah, that's the challenge that we set ourselves, right? Like, when we started the company, we wanted to build a general purpose explainable AI platform, which meant that we should be able to digest multiple types of models and then be able to explain them. So far we have gone quite far. We can actually digest TensorFlow, PyTorch, scikit-learn, XGBoost type of models pretty quickly. And now we are adding support for MLflow, Spark, and then other type H2O type of models. One of the things that has really helped us is the container technology maturity. I think people are now moving towards more and more kind of Dockerizing their models. So so that ability to kind of have Docker being one level of abstraction. So instead of we looking at the model artifacts, we can be looking at Dockerized containers with a standard API that is implemented. So then essentially we can standardize our explainability algorithms to just work on that API. So as long as you can actually give us input, if we can pass inputs and you can give us inputs, we can send us outputs, then we can basically explain that model today, right? So those are the things. It's still a lot of work needs to be done here, as I said. For like applying complex explainability algorithms like integrated gradients, you need much more access to the model. For example, the gradient vectors of the outermost layer and whatnot, in which case you would need like the model artifact, right? So in that case, being able to take the model artifact and run it, and then run it across different versions of TensorFlow and whatnot, is a huge challenge. So we kind of have built the system to scale for that. It's a hard problem to solve, and come very far from where we were 2 years ago, but still like a lot of way to go.
nice. PyTorch, is that
right? PyTorch too. Yeah, we have a partnership with Facebook AI. So there's Facebook has this library called Captum. It's pretty neat library to explain PyTorch models. So Fiddler uses Captum as internally to kind of explain PyTorch models. So yeah, you can use Fiddler for PyTorch. Yeah,
I would hope so, considering your background.
correct. Yeah, we have a good partnership with Facebook AI Research, and we're working towards kind of evangelizing Fiddler and the PyTorch community.
It has come to the point where we need to choose these swag winners. Krishna and I are going to look through, and we're going to tell each other in the chat who we think should win the swag. For everyone that is here with us, I really want to thank you for these incredible questions. This was awesome. This has been super insightful, and I love hearing how you all are looking at things and what is important to you, really. And judging by the quality and caliber of questions that came through, it seems like this is front of mind for a lot of people, which is reassuring to me, because I like to talk about how important monitoring is all the time, but sometimes I wonder if anybody is actually listening. And it seems like there are people that are out there listening, and the explainability part of this, Krishna, has been really useful to dive into what exactly it is, because it is a buzzword being thrown around. It's a buzzword within a buzzword of MLOps. And so sometimes you have to really sift through a lot in order to get there and figure out what it means and what it actually does and why it's useful. So let's see. Krishna, should I leave it to you, or are you going to let me
No,
choose?
please do the honors. You please select, the people.
I think we got to go with Ron's, man. He quoted an article and everything. He did that was some serious stuff that happened for Ron. And then I really liked the question from, I did like the question from Deepesh also about how to navigate politics. And I thought your answer was especially good, because this is where explainability can shine. So maybe we can give it to Ron and Deepesh, and everyone else. Thank you again. We're going to be giving away more Fiddler swag. Don't worry, especially as much swag as they let me, I'm going to give it all away.
Absolutely.
But for Ron and Deepesh, please reach out to me or reach out to Krishna in the Slack, and we will send you the swag bag. And thanks again, Krishna, for doing this, man. This is super insightful.
Absolutely. Thank you so much, Demetrius. Yeah, and it was a great, great set of questions. Thanks to the audience for joining in.
Yeah, thank you. Thank you all. We will see you later. See you next time. And if you want to follow up the conversation with Krishna, he's in this Slack. So ask away, ask any questions. We also have an Explainability AI Slack channel. So for more of these questions and more of the news that's on this, jump in that Slack channel that is in our Slack workspace, because that is a happening place. It's where all the cool kids are.
Correct. Yep, absolutely. Awesome. Thank you so much. And yeah, have a nice day, everyone. Bye-bye.
See you, everyone.